Good day everyone, we're back again to our online bridging course. So this time we'll be discussing about complex numbers. First off, let us discuss about the imaginary unit I. So for instance, the quadratic equation x squared, so take a look at this. The quadratic equation x squared plus 1 equals 0 has no real solution because if we solve for x in this equation, x squared plus 1 equals 0, the result would be x is equal to the square root of negative 1, which is this, square root of negative 1. So we cannot extract the square root of a negative number, or the square root of negative 1 does not exist, or is not real. So we denote the square root of negative 1 as I, or simply we define I, or the imaginary unit I, as the square root of negative 1. So therefore, if we square both sides, I squared becomes negative 1. By adding real numbers to real multiples of this imaginary unit, the set of complex numbers is obtained. Each complex number can be written in the standard form a plus bi. For instance, the standard form of the complex number, this, a negative 5 plus the square root of negative 9. Again, the square root of negative 9 is not real. So the standard form is negative 5 plus 3i. Okay, or that would be negative 1 times 9, and we extract the root of 9, that would be 3 times the square root of negative 1, so that's 3i. This. In the standard form a plus bi, the real number, or a, this one, is the real part, and bi is the imaginary part. The real part and the imaginary part comprises the complex number a plus bi. Okay? So the definition of a complex number is this. If a and b are real numbers, the number a plus bi is a complex number, and it is said to be written in the standard form. So this is the standard form, a plus bi. If b is equal to 0, the number a plus bi, so if b is equal to 0, the number a plus bi is just equal to a, or just a real number. If b is not equal to 0, the number a plus bi is called an imaginary number. Okay? A number of the form bi, where b is not equal to 0, is called a pure imaginary number. Okay? So in contrast with what we discussed about real numbers, complex numbers are numbers that contains an imaginary part. So when we say imaginary part, this does not exist in real life, but the concept of complex numbers is very useful, especially in engineering studies. So complex numbers, again, looking at this graph, complex numbers is composed of a real part, which is a, and the imaginary part. That's complex numbers. Take a look at these definitions. Equality of complex numbers. Two complex numbers, a plus bi and c plus di, written in the standard form, are equal to each other. A plus bi is equal to c plus di if and only if a is equal to c and b is equal to d. I think that's just common sense. So a plus bi is equal to c plus di if a is equal to c and b is equal to d. That's too easy. Okay, for example, we have 2 plus 3i. That is just the same as 4 over 2 plus 6 over 2i, because they are the same. 2 is just the same as 4 over 2, and 3 is just the same as 6 over 2. So let's proceed to the operations with complex numbers. To add or subtract two complex numbers, you add or subtract the real and imaginary parts, or imaginary parts of the numbers separately. Okay, it's just the same as combining like terms in polynomial expressions. So addition and subtraction of complex numbers. If a plus bi and c plus di are two complex numbers written in standard form, their sum and difference are defined as follows. So if we have a or this quantity a plus bi added to another quantity plus di, we just add, or we group the real part and the imaginary part. So we just add the real part and add the imaginary part. For difference, you subtract the real part, then subtract the imaginary part, or the properties of the properties in algebra could also be used to this. If you take away the parentheses here, just a plus bi, and you distribute the negative to the parentheses, or inside the parentheses, that would be, let's repeat that, a plus bi minus c minus di. So this time, I'll just combine these two, a minus c plus bi combined with this, minus di. Then we factor out I, that would be this one. Or simply, we just subtract the real part and subtract the imaginary part. And that's it. So I think it's time for our first example. Let's try these examples. Let's call this problem for lesson 9, number 1. Adding and subtracting complex numbers. So we have this first problem here. This is just too easy. Again, we just need to add the real part and then the imaginary part. So we do it like this. First, add the real part. So 4 plus 1 plus, add the imaginary part. That would be 7i minus or plus negative 6i, or 7i minus 6i. So the result is just 5 plus 1i, or I. Okay, or you may approach it like this. You just remove all the parentheses since positive naman dito. So you'll have 4 plus 7i plus 1 minus 6i. That would be equal to 4 plus 1 plus 7i minus 6i, or 5 plus i. So still the same. For letter C, we have this. Again, sobrang madali pa rin. The first complex number don't have a real part. So, ganun pa rin. You just combine this with all the imaginary parts. So, let me rewrite this into this one. I'll distribute this. That would be 3i plus 2 minus 3i minus 2 minus 5i. I distributed it here. So, we have this. Okay. Then combine all the real parts. So we'll have 2 minus 2, 0. And the imaginary parts, 3i minus 3i, cancel that out. Negative 5i is left. So the answer is just negative 5i. And that's it. Too easy. Okay, last for the first problem. Again, the best thing to do here is just to expand 3 plus 2i plus 4 minus I minus 7 minus I. Okay, again, distributing the negative sign. So, combining the real parts, we have 3 and 4 and negative 7. So, 3 plus 4 is 7 minus 7, that would be 0. So, 2i, so the real part is 0. And for the imaginary part, 2i minus I is I minus I, 0. So, the result is 0. Okay, sulat na lang natin. 3 plus 4 minus 7 plus 2i minus I minus I. So, all of these will result to 0. The answer is simply 0. Let's now proceed to our next example. Let's try this one. Sige. So, let's name this problem 9-2, multiplying complex numbers. For letter A, we have this. How do we multiply complex numbers? Madali lang din to. If we have two sets of complex numbers, each having a real and imaginary part, we just treat it as the same as polynomials, or when we are multiplying binomials. So in the first case, negative 2 plus 3i is multiplied by 4. So we just apply the distributive property of algebra. Just distribute 4 inside the parentheses. So that would be negative 8 plus 12i. And that's it. Too easy. For the second problem, we treat this as binomial. First term, second term, first term, second term. So two sets of binomials multiply to each other. So again, we'll use FOIL. First, outside, inside, and last. Okay? Or usually, ginagawa natin, we do it like this. Ganito yung pagka-multiply. Oh, sorry. That would be 2 minus I and 4 plus 3i. Then we multiply like that. That would be okay. Bottom line, we treat this as a binomial. Okay. So 2 times 4, that would be 8. Then 2 times 3i, that would be 6i. 6i. Then next, Then next we'll have negative I times 4. So that's negative 4i. And negative I times 3i. So that would be negative 3i squared. Remember that I squared, or the definition of I, is the square root of negative 1. Hence, I squared is negative 1. So therefore, this is just negative 1. We'll write this as 8 plus 6i minus 4i. Sorry. Let's combine these two. 6i minus 4i, that would be 2i, plus 2i minus 3, and I squared is just negative 1. So this would be positive 3 added to 8, that would become 11. So 11 plus 2i is our final answer. Okay, lagyan natin ng detail dito konti. So 8 plus 2i plus 3. So 8 plus 3 is 11 plus 2i. So that's it. Okay, we still have this for letter C. Again, the approach here is like expansion, diba? Or just multiplying two binomials. But in this case, you notice that the second term is just the conjugate of the first term. They are similar, only that the second term is the additive inverse of the second term of the first factor. Okay, so if you recall, if you multiply a plus b and a minus b, the result is a special product, a squared minus b squared. So therefore, this is simply 3 squared minus 2i squared. The result would be 9 minus 4i squared. So 9 minus 4, and I squared is negative 1. So we have 9 plus 4. The answer is 13. That's it. Napakadali. Now let's proceed to letter D. For letter D, again, we treat this as a binomial, then we square. So what is the square of 3 plus 2i? So ganun pa rin, if you recall again sa discussion on polynomials, di ba, we have a plus b. If we square that, the result is a squared plus 2ab plus b squared. So we just follow that, or maybe you can do 3 plus 2i times 3 plus 2i, then you do FOIL. But we'll just do the formula, or you just follow the formula. So that would be the first term squared, so 3 squared plus 2 times the first term times the second term plus the square of the second term, so 2i squared. So that would become 9 plus, so you multiply this, that would be 6 times 2, so that's 12i plus 2 squared is 4 times I squared. And again, I squared is negative 1. So that would be 9 plus 12i plus 4 times negative 1. We'll have 9 plus 12i minus 4. And again, combine the real part, 9 and negative 4. So that would be 5 plus 12i. So the result is just 5 plus 12i. This is the square of 3 plus 2i. That's it. Let's continue. Let's try to take a look at this complex conjugates. Okay, notice in example 2C. Asan ba yung example 2C? That's in the previous example, this one here. The two um, complex numbers are just complex conjugate of each other. Or that the product of two complex numbers can be a real number. So this occurs with pairs of complex numbers of the form a plus bi and a minus bi. So if we have two complex conjugates multiplied to each other, the result is just a real number. Okay? Or a plus bi times a minus bi is just simply a squared plus b squared. So we are just following the formula for special products. Diba? We have a squared minus, that would be a squared minus bi squared. So that would be a minus b squared times I squared. Since I squared is negative 1, so that becomes a squared plus b squared, or this. That is the result of multiplying two complex conjugates, or multiplying complex conjugates. So again, it's called complex conjugate because first it's a complex number, and conjugate because the second term is the additive inverse of the other factor, or the second term of the other factor. Now let's try to take a look at this. This is problem 9-3. Multiply each complex numbers by its complex conjugates. Again, that's too easy. For letter A, we have 1 plus I. So if we have this, again, ito nang naman yung formula natin, di ba? If we have A plus BI multiplied by A minus BI, the result is just A squared plus B squared. Diba? So if we multiply 1 plus I, multiply 1 plus I by 1 minus I, the result is just 1 squared, okay, plus 1 squared. The result is just 2. Ganun lang. Or kung medyo gusto natin complex ng konti, kompleto yung solution, we'll have 1 squared minus I squared. Ganun. So 1 squared is 1 minus I squared is negative 1. So the result is still 2. How about for letter B? Just applying the formula, we'll have 4 minus 3i. We multiply by its complex conjugate 4 plus 3i. The result is just 4 squared plus 3 squared. Or that would be 16 plus 9 or 25. Okay? Or kung pwede din natin pahabain, special product, by special product, we have 4 squared minus 3i squared. So that would be, or to second solution. 4 squared is 16 minus 3 squared is 9 and times I squared. So that would be 16 minus 9 times negative 1. So 16 plus 9 equals 25. So ganun pa rin. Either way, you still arrive at the same answer. Okay? Now let's take a look at another one. This is problem 9-4. Call this problem 9-4. Writing a quotient of complex numbers in standard form. Okay, take a look at these complex numbers, or this is a quotient of two complex numbers. So we do that by first multiplying the denominator by its complex conjugate. Okay. The procedure is just the same as rationalizing the denominator. So we solve this by first, let's rewrite this first. Okay, ayusin natin. 4 minus 2i. We multiply it by its complex conjugate. We have 4 plus 2i, or the complex conjugate of the denominator. Complex conjugate, I mean. So 4 plus 2i. So medyo i-detail muna natin yung solution. So we'll have 2 plus 3i multiplied by 4 plus 2i, then divided by complex conjugates, or the product of complex conjugates. 4 minus 2i and 4 plus 2i. Okay, yung sa numerator, we just follow again FOIL. That would be 2 times 4, 8. 2 times negative I, that would be 4I. Then plus 12I. Ito na yan. Then dito, last, plus 6I squared. Tama ba? Okay, check natin mamaya. Then divided by, again, we know how to multiply complex conjugate. So we'll have 4 squared plus 2 squared. Wala pa. So 4 plus 4I plus 12I. So that would be 16I. 16I plus 6 times negative 1 divided by 16 plus 4. Okay? So, combine these two, we'll have 8 minus 6. So, we have 2 plus 16i. Then, divide it by, how about here, that's 20. So, we have 2 plus 16i over 20. So, finally, we'll have, in standard form, again, yung standard form natin is a plus bi, diba? So, we just rewrite this as 2 over 20 plus 16 over 20i. Okay? This is, ang ibig sabihin nito is just, we divide these terms by 20. Meaning, we divide by 2, ang 2 by 20, and we divide 16i by 20. So, ganun lang naman yun. Okay? So, 2 over 20 is just 1 over 10, plus, how about 16 over 20? 4 over 5i. So, that would be our answer. In the standard form of this is this. Now let's take a look at another definition. Principal square root of a negative number. If a is a positive number, the principal square root of the negative number, negative a, is defined as square root of negative a is just equal to negative ai. Notice na yung I should be outside the radical. Or this is actually the same as I square root of a. Okay, I is outside the radical. Or simply, we just extracted negative 1 from the radical sign. So it becomes I. Okay, or that is simply square root, let me rewrite that, square root of negative 1 times a. So square root of negative 1 is I, then nabilin si a. Naiwan si a sa loob ng radical sign. So the result is just square root of a I. Ganun lang. So let's try to take a look at this. This is problem 9 dash, I think it's 4. 9 dash 4. Okay, 9 dash 4. Writing complex numbers in standard form. Okay, we have the product or a product of two square roots of a negative number. So, anong pwedeng gawin natin dito? Calculator. Pero, if you want to solve this, pwedeng ganito. We just, pareho naman silang naka-square root. We just combine it into one square root. So, ipasok natin lahat. So, that's negative 3. And how about if ang negative 12, I'll rewrite that to negative 3 times 4. Ganun. So, that would be the square root of negative 3 times negative 3. That's 9 times 4. So, eto pala siya. This is just 3 times 2, or this is just 6. Real number lang. Okay? How about for letter B? Let's start with this square root of negative 48. So, negative 48 is just the product of 3 and 16. Diba? And 16 is a perfect root. So, I can rewrite this as negative, let's say negative 1. Isali natin si negative 1. Negative 1, that would make that negative. Negative 1 times 3 times 16. Okay? Minus, how about 27? 27 is 9 times 3. So, negative 1 times 9 times 3. Okay, now, take a look at this. 16 is a perfect square, so we just extract that. So that would be 4. And this is I, or negative square root of negative 1 is just I, sorry. Hence, etong first term natin magiging 4, extracted si square root of 16. I, extracted kasi si square root of negative 1, and naiwan sa loob si square root of 3. Minus, how about this? We extract 9, or the square root of 9 is just 3. And we extract square root of negative 1, so that's I. Naiwan ulit si square root of 3. And these are just like terms. So, what is 4I, or that's 4 square root of 3 minus 3 square root of 3? So, that is simply square root of 3. So, the answer is square root of 3I. Nakuha? You treat this as like a variable. Although it's not a variable, pero parang ano to, it's the same as 4x minus 3x. So we just treated this as like x. Diba? So 4x minus 3x is x. Ito yan. Okay? How about this one? Ito siya, we just need to square this binomial. So we know the formula. That would be negative 1 squared plus twice of Before we do that, extract muna natin si I. Extract natin si I. So, we'll rewrite this as negative 1 plus, that would be square root of 3I. Diba? We extracted negative 1. So, ilabas natin si square root of negative 1. So, that would be I. Naiwan sa loob si square root of 3. Then, we square that. So, following the formula, we'll have negative 1 squared plus twice of the first term times the second term. Sorry, that would be 3I. Again, nasa labas yung I. Then, plus the square of the last term. So, that's square root of 3I. Square of that. So, that would be 1. So, what will happen dito? That would be negative 2 square root of 3I. Ito, you just multiply this, then I. Plus, square root of 3 squared is 3. And I squared is, syempre, I squared, which is negative 1. So, 1 minus 2 square root of 3I plus 3 times negative 1. So, what would be our final answer? Or in its standard form. So, this would become negative 3. So, 1 minus 3 is negative 2 minus 2 square root of 3I. So, that is our standard form. Okay, let me highlight the answers para sa inyo. Okay, this is the answer. Kani, and this one. Okay, actually for letter A, ito pala, pansinin muna natin to. Actually for letter A, the square root of 36 has two values, positive and negative 6 pala. So ito, we just ignored using I dito, no? So yung lumabas sa solution natin is 6. Pero if we consider I, that would be square root of 3I times square root of 12I. So yung lalabas na answer dito is yung negative value niya. Okay? So that would be square root of 3I. Ito. Square root of 3 times square root of 12 is square root of 36 times I squared. So square root of 36, if we use the positive value of the square root of 36, that would be 6 times I squared, which is negative 1. So that would be negative 6. So I think we have two values for, or two answers for letter A. The square root of 36 is just positive and negative 6. Now let's take a look at another example. This one. Complex solutions of a quadratic equation. Okay. In the previous lesson on quadratic equations, we learned that a quadratic equation could either have two unique solutions or two unique values for x, Or we could have one unique value, or one value pero repeated siya, or repeated roots. And it could also be a complex conjugate, or wala siyang real value. Let's try to solve these quadratic equations. Let's call this problem 9-5. Complex solutions to quadratic equation. So for letter A, we have x squared plus 4 equals 0. Of course, solving for x, we don't need to use a formula kasi madali lang naman to. Hindi naman siya trinomial. So we have x squared equal to negative 4 and x is equal to the square root of negative 4. So that would be square root of 4i, right? Or this is 2i, or to be exact, kasi dalawa yung solution niya because this is a quadratic equation, meaning we have two values for x. So the answer is just positive negative 2i because the square root of 4 is positive and negative 2. Ganun lang siya kadali. How about letter B? For letter B, we have 3x squared minus 2x plus 5. We have two ways of solving this. We can do completing the squares or just a quadratic equation. So using the quadratic equation, we have x is equal to negative b plus minus square root of b squared minus 4ac, the discriminant, all over 2a. Okay, we can use this formula since we know that a is 3, b is negative 2, and c is 5. And then substitute. So we'll have x is equal to negative of negative 2 is positive 2 plus and minus the square root of, ayusin natin, kaya that's the square root of b squared. So what's b squared? That's 4 minus 4, which is 4 times ac. 4 times a, 3, and c, 5. And all over 2 times a, which is 3. So, continue natin. We'll have 2 plus minus the square root of, take a look at this. So, mani negative siya. So, this is actually 15 times 4. Tama ba ito? 15 times 4. So, that's 60. So, 4 minus 60 is 56. 56. And negative 56, ang factor niya is pwedeng negative 1 times 8 times 7, di ba? 8 times 7. And further, 8 is 2 times 4, and 4 is a perfect square. Pwede natin ilabas. So, nag-iwan si 2 times 7, which is 14. Ayan. So, divided by 6. So, we'll have x is equal to 2 plus minus, ayusin natin dito ha. This becomes negative 1 times 4 times 14. Tama ba? Sorry. Negative 1 times 4 times 14. Ito. So that would be 2i times square root of 14. Or let me rewrite that as 2 square root of 14i. Then divided by 6. Okay. So, ito, that would be 2 over, sige, ayusin natin. That would be 2 over 6 plus minus 2 square root of 14 over 6i. Hence, this is 1/3 plus minus square root of 14 over 3i. So, this is the answer by using the quadratic equation. You can also try to solve this using completing the squares and you will arrive at the same answer. Okay, that's it. So let's try to answer some exercises. Bawasan natin yung mga exercises na isa-solve nyo. But I think madali lang naman. No? Let's just try to pick some. Dito tayo agad sa baba. Performed indicated. Medyo madali. Ito na lang. Let's try to do this one. Perform the operation and write the result in standard form. Let's try 2 over ito. Complex conjugate lang naman yung sa ilalim, no? So, let's try to solve this one. So how do we do that? Again, get the LCD. Kasi mga fraction siya, di ba? So I'll get the LCD of this. That would be the product of the conjugates. 1 plus I times 1 minus I. Okay? Then this divided by this is 1 minus I times 2. So that would be 2 times 1 minus I minus, ito, this divided by this is 1 plus, makakansela to. So 1 plus I times 3. So that's 3 times 1 plus I. Then we have to simplify. We'll have 2 minus 2I minus 3 minus 3I over. So what will happen dito? So 1 squared plus 1 squared. So we have 1 plus 1, 2. Okay? So anong susunod? Wait, na-distract ako dito. Dapat nasa gitna. Ayan. So 2 minus 3 is negative 1. Then negative 2 minus negative 3, both ay may I, is negative 5I divided by 2. So in standard form, that would be negative 1 half minus 5 halves I. So ito yung answer natin. I think kayang-kaya na all the rest of the problems. Sobrang dali. Ito, pareho rin naman dun sa example natin. I think that's it. Sobrang dali pala ng lesson na to. And when we discuss about functions, we will try to look at asan sa graph yung mga negative o yung mga complex numbers or yung mga imaginary numbers. Kasi of course, wala siya sa real line. Kasi imaginary siya. Yung real number line is just comprised of all real numbers. So yung imaginary numbers will not be found at that real number line, of course. So we will be discussing that in maybe more thoroughly when we discuss about functions. So, and we will see you again in the next